Hello my amazing students, this is Mrs. A and we are starting our little videos that I told you I would make for you, giving you the answers to the homework problems that I have assigned you. So this is 3.1, which is the first section that I really feel like you need videos because the others were pretty much cut and dried. But 3.1 starts the calculations of things like mean, median, and mode. So that's what I'm going to do for you today. So the first problem we're going to do is number 5. So on each one of these problems, we were just supposed to come up with the mean, the median, the mode, the mid-range, and then answer the given question. So in this case, in the answer solution manual, they've already given us the mean and they've shown us the calculation. So I'm going to show you the calculation for the median, which they say is 60. So the first thing in finding the median is we have to put them in order from lowest to highest. So then we will basically match the lowest point with the highest point and discard them. The next lowest point with the next highest and discard them. The next lowest to the next highest. So I'm basically doing a matching of pairs. And when I finish doing that, I wind up with the very middle number being 60. Now notice I have to have these in order before this will work. And notice that I've counted in 1, 2, 3, 4, 5, and I have counted from the other side 1, 2, 3, 4, 5, and those 5 on each side. Then we have the middle is the median, 60. Move on. There is no mode because there is no repeated point in all of these. Remember, the mode is the repeated point. The mid-range is the lowest plus the highest, so 7 plus 99, and then I divide by the number of points. That is my mid-range. They're showing you the calculation for the mid-range. Minimum value plus maximum value divided by the number of values present. So the mid-range is 53. And then they asked us why was the median and the mode irrelevant and meaningless. In this case, even the mean is meaningless because these are just football jersey numbers and they really have no meaning. So the mean, the median, the mode are all meaningless. It's just nominal data. Okay, so we're going to go back to number 5. I just realized that in the answer key here, there is an error on the mid-range. It should have been divided by 2 and not 11. The answer, 53, is correct, but the calculation is incorrect. It should be 7 plus 99 divided by 2, and I will slide this into the video to correct that. So here we're talking about celebrity net worth. It says listed below are the highest amounts of net worth in millions of dollars of celebrities. The celebrities are Tom Cruise, Will Smith, Robert De Niro, Drew Carey, George Clooney, John Travolta, Samuel L. Jackson, Larry King, Demi Moore, and Bruce Willis. What do the results tell us about the population of all the celebrities? Based on the nature of the amounts, what can be inferred about their precision? Okay, so then we come over here, and here is the answer set. So again, we're trying to find mean, median, mode, mid-range, and notice how they answered the question. Apart from the fact that all other celebrities have amounts of net worth lower than those given, nothing meaningful can be known about the population of net worth of all celebrities. The numbers all end in 5 or 0, and they appear to be rounded estimates. So there's not much we can say about all celebrities because we've only gotten the top 10 listed here. But they're already showing you the calculation of the mean, which remember is just adding up all the values and dividing by 10 since there were 10 values. The median, however, so here's my board that I prepared for the median, and notice at the top I put them in the order they were given. At the bottom I put them in numerical order from left to right. Okay, so then when I move 4 spaces in, 4 data points in, and then I move 4 data points from the other side, I end up with 160 and 160 because I have an even number of data points, 10 data points. I end up with two values in the middle. So my procedure is to always take the average when I have two data pieces in the middle, but 160 plus 160 divided by 2 is still 160. So my median should be 160. It's exactly what they showed you right here. 160 plus 160 over 2 is the median. The mode is 150 million because you saw 150 in there 4 times. The mid-range is the lowest plus the highest divided by 2 because it is the average of the lowest value and the highest value. And then lastly, it says apart from the fact that all other celebrities have amounts of net worth lower than those given, nothing meaningful can be known about the population of net worth of all the celebrities. The numbers all end in 0 or 5 and they appear to be rounded estimates. So now we're working on problem number 17. Listed below in dollars are the amounts it cost for marriage proposal packages at the different Major League Baseball stadiums. 5 of the teams don't allow proposals. Are there any outliers? Okay, so the very first thing we would have to do with this long string of data is to put it in lowest to highest order. When we look at the answer set, they have taken the data and put them in lowest to highest order and divided by 25. Since we have 25 data points, that is an odd number, and our median should be the exact center, because when we have an odd number, we have a center piece of data, and the center piece of data is 200 when we match the pairs of data from the outside in. So the median of the first set was 200. Okay, I just checked our data and the median really is 200 because if you count 12 in and count 12 from the other side, you're left with 200. I think this 500 is an error. So you should scratch this. The median is not 500. This is an error in the answer key. The mid-range is going to be the lowest value, 39, plus the highest value, 2,500, divided by 2. And then the top 2 appear to be outliers because they are so much higher than all the others. So 1,500 and 2,500 appear to be outliers in this problem. Okay, on problem 29 here, we are supposed to find the mean of this frequency distribution. When we're doing a mean of a frequency distribution, we have to realize that we no longer have all the data points. We have 29 data points here that are represented by one number, 29. That's 29 data points that are somewhere between 20 and 29. 34 data points that are somewhere between 30 and 39. So in order to do this, what we're going to do is we're going to take this range and we're going to find the midpoint of that range. And then we're going to take the midpoint and multiply it by 29. We're going to take the midpoint of this range and multiply it by 34 and so on. Then we're going to add them all up and divide by the total frequency, which is the sum of all of these numbers. So remember, to find a midpoint on a frequency distribution, we add the 20 plus the 29, which would give us 49, and then we would divide by 2. And 49 divided by 2 would give us 24.5. So here we're back on the answer key, and you've got 24.5, which is the midpoint of the range, 20 to 29, and we're multiplying it by 29 because that was the frequency of the first set of numbers, the first class. As you see, 20 plus 29 divided by 2 is 24.5, and we multiply the 24.5 by the 29. Here is the 24.5 multiplied by the 29. So then we go to the second class, And here we have 30 plus 39, which are the class endpoints here. 30 plus 39, and that's going to give us 69. We divide that by 2, which is taking the average, and we're going to get 34.5, excuse me, 34.5. And then we're going to multiply that by 34. And there's the 34.5 multiplied by the 34. And we're going to do the same thing for the 3rd class, the 4th class, the 5th class, the 6th class, and the 7th class. Okay, and then we're going to divide that, which is the midpoint times the frequency of each class, and we're going to divide it by all of the frequencies added together. And see, this was a frequency, there it is again. This was a frequency, 34, there it is again. So we add up all the frequencies and put it on the bottom. When we crank out all of that math, we wind up with 36.2 years. Okay, so then it says this is the same mean as the 36.2 years you would have found if you had used the original list of data values. So the midpoint turns out to be very accurate in finding out the mean. So we take the midpoint, multiply by the frequency. We do that for all of the classes, and we divide by the total frequency, which is the sum of all of the individual frequencies. So there's number 29 that you're focusing in on there. Okay, so let's look at the last two problems, which are 33 and 34. Okay, it says a student of the author earned grades of A, C, B, A, D. Those courses had the corresponding numbers of credit hours 3, 3, 3, 4, 1. The grading system assigns quality points to letter grades as follows. A is 4, B is 3, C is 2, D is 1, F is 0. Compute the grade point average GPA and round the result with 2 decimal places. If the Dean's List requires a GPA of 3.00 or greater, did this student make the Dean's List? Okay, so we're going to do that one by looking first at the answers in the answer book. I want you to see, notice that we've got letter grades, we've got weights, okay, and each grade is given a value. So let's look up here at 33. The mean is X bar, and this is called a weighted mean because each one of the items had a different weight, and it's done very much like a frequency distribution mean would be done. So we're getting up here that we had a 3-hour class that the student made an A in. Okay, so the first one was an A. Okay, so I made you this little chart here, which I thought might help you out a little bit. So the student made ACBAD, and then the author of the book matched. The A was a 3-hour course, the C was a 3-hour course, the B was a 3-hour, so forth and so on. And then when it says the A's are given 4, those are called quality points usually. So A is worth 4 quality points, C is only worth 2, B is worth 3, A is worth 4, again, they're consistent, and D is 1. Okay, F's get 0 quality points. So now we're going to take the number of hours times the quality points. So 3 times 4. And the number of hours times the quality points, 3 times 2. 3 times 3. 4 times 4. And 1 times 1. Okay, so he winds up getting, as far as his over total points, he's got 12, 6, 9, 16, and 1. And now he's going to add all of these up together. So 12 plus 6 is 18. And then we have a 9 is 27, 28, 34, 44. So altogether, he's got 44 points, okay? And then he has to divide that by the number of hours that he has accounted for. So he has got 9, 10, 14 hours. So he's going to divide 44 by 14. When he does that, he's going to get a 3.143. I just did that on my calculator. And he's rounding to 2 decimal places, so he's going to get a 3.14. Here's the calculation as it was made in your answer key. And all they're doing is adding up what I just added up and dividing by the total number of hours the student took that semester. And since he got a 3.4 and a 3.00 was needed for the Dean's List, he made the Dean's List. That was the end of problem 33. Okay, so lastly, we're going to go to problem 34. Problem 34 says a student of the author earned grades 63, 91, 88, 84, and 79 on her 5 regular statistics tests. She earned grades of 86 on the final exam and 90 on her class projects. So her final exam was 86 and her class projects were 90. I'm writing these down as I talk so that I have them. Okay, her combined homework was a 70. So she could have improved on that, I think. And the 5 regular tests count for 60% of the final grade. So the 5 tests are going to count for 60% of her grade. And the final exam counts for 10%. Projects count for 15%. And the homework counts for 15%. Okay, what is her weighted mean grade? What letter grade did she earn? A, B, C, D, or F? Assume that a mean of 90 or above is an A, a mean of 80 to 89 is a B, and so on. Okay, so here is the data as I jotted it down. Okay, she's got 5 test scores, and that's going to be 60% of her overall grade. So we'll put a percentage sign there. And then she's got final 86. That's 10%, projects 90, that's 15%, and 70 was her homework. And I forgot to write that down, homework. And she has that as 15% of her grade. So what we're going to do is we're going to take the 5 tests and we're going to get the average, which means I'm going to add them all together, divide by 5, and then I will multiply that by 0.60. because it is 60% of her grade. At the very top of my computer screen, you see the calculation. We take all 5 tests, we add them up together, divide by 5, and that gives me my test average. Then I multiply it by the 60% or the 0.60 because that's what tests are worth. Then she got an 86 on her final, but her final was only worth 10%. She got a 90 on her projects, and her projects were worth 15. She got a 70 on her homework, and her homework was worth 15%. When you multiply and add all of that together, you get an 81.2. So the student earned a B in the class because an 81 would have been a B. That is the end of 34 and our first homework assignment 3.1. I hope this has been helpful. Thanks for joining me on 3.1, and I'll be back with 3.2 in a minute. This is Mrs. A, and may God bless your day.